Hey guys, this is test 44 game 1. This is the client Dignitaries game with Garibaldi. It's an ordering game. We know this because we're determining the order in which Garibaldi has these meetings with each of the foreign dignitaries. The initial paragraph might not make it clear, but the rules do. It tells us, like for example, in the second rule, the idea of having meetings in a row tells us that there's an order in which the meetings occur. So for this reason, we know it's an ordering game. We've got 7 slots here. I've already diagrammed the rules, but I'll explain all of those. We've got 3 with fuentes, so I put down 3 Fs, and then each of the other dignitaries going once. So 3 Fs and then MRST are the 7 variables that we are placing. We know that Fs never occur consecutively, so I put FF with a slash through it. We know that S is the next after T, giving us a TS horizontal box because they're occurring next to each other in that specific order. And finally, M is not on 1 and M is not on 7. If you wanted to, you could put down S is not on 1, T is not on 7. I'm not going to bother. But anyway, that's our initial setup for the game. Now, question number 1 is our typical orientation question. You just want to take one rule at a time and apply that rule to all 5 choices, looking for violations. So for example, we could look for TS occurring consecutively in that specific order. Running through the choices, we find that choice D as in Delta does not have them occurring consecutively in order. There is both M and F in between them, which is unacceptable, so for that reason D is gone. Next, you could take the rule that Fs never occur consecutively. Running through the choices, you find that choice B has F on 5 and F on 6, and of course that's a little bit tricky to spot given that they're separated by the line break, but they are still consecutive, so B is gone for that reason. Next, you could look for the idea that we have to have M not on 1 and not on 7. Choice E has M on 7, unacceptable, so E is eliminated. And finally, look for the idea that there have to be 3 Fs in the game. We have F on 1, F on 5, but that's only 2 Fs, not 3 in A. So for that reason, A is gone, leaving C as our answer to number 1. Next, number 2, if R occurred on 7, that's essentially what they're telling us here. So it still leaves things pretty open-ended. We don't know exactly where, for example, the 3 Fs are going. So it's very open-ended. There's no specific particular layout to use here. So for that reason, I'll just run through the choices. Now, you'll run into a problem if you have, for example, S on 2. If S was on 2, we would need to have T on 1, and then we'd have no room for the 3 Fs to occur without going adjacently at some point. So for that reason, A is eliminated. Next, look at B, M on 3. If M was on 3, we would not have room for a TS box as well as the 3 Fs without occurring consecutively. For example, if we had maybe F on 1, F on 4, and F on 6, no room for a TS box. And if we had F on 2, same problem. So for that reason, we cannot have B occur either. We can't have M on 3. Looking at C, S on 4. S on 4 requires T on 3. We could easily fit a TX box. We are easily fit a TS box, of course, but where are our Fs going to occur? We could have one of them on the 1, 2, one of them on the 5, 6, but where would the third go? It just doesn't work. So for that reason, choice C is eliminated. Next, D, M on 5. If we put M on 5, we could have F on 6, and then we could also have F on 4 and F on 1. And then we could easily fit TS on 2 and 3. It works out fine. We comply with all the rules. For that reason, D is our answer. And I will just take a quick look at E. I'll draw a separate one here on top. If we were to put S on 6, and of course we have R on 7 already, S on 6 requires T on 5. You could have 2 of the Fs, maybe on 1 and 3, or 2 and 4, or 1 and 4, but you wouldn't be able to fit all 3 of them. So for that reason, that's a bad diagram, and E is eliminated for number 2, leaving D as our answer. Next, number 3, if we put F on 2. So then who could be 4th? So if F is on 2, of course, we could have maybe, of course, I want to always think about the 3 Fs and the idea that Fs cannot touch. So we could have F on 4, F on 6, F on 4, F on 7, F on 5, F on 7, many different possibilities here. So for that reason, it is possible to have F on 4. That could occur. So for that reason, any choice not mentioning F is automatically eliminated, getting rid of B, C, and D. So now the question is, could we have only F and S there, or could we have any of F, S, or R? So the way to test this is to find out whether R works. If R works, A is our answer. If R does not work, E must be our answer by process of elimination. So I'm going to put R on 4 and see what happens. Well, we've got to have an F occurring somewhere within the last 3. And we've also got to have the TS box. The TS box could not occur on 1 or 3, of course, because those are separate. We'd have to have the TS box occurring on either 5, 6, or 6, 7, alternating with F. But the problem then is, where does the third F go? It can't go on 5, 6, 7. We've already got the second F and then TS there. And then the third F can't go on 1 or 3 because it would be adjacent to F on 2. So for that reason, R on 3 is not possible. A is eliminated, leaving E as our answer to number 4. Now, if you want to know why S on 4 works, well, it's because if we had S on 4, we'd have T on 3. We could have F on 5, and then F on 7. Then we could have M on 6, and R on 1. So R, F, T, S, F, M, F. Works out perfectly fine to have S on 4. That's why E is our answer to number 3. Next, number 4, if R is the next one after S. So I've got R is the next after S. We've also got T occurring before that due to the TS box. So they are a complete box. Now they're asking us in general what must be true. So I'm just going to lay out a diagram here with TSR on 2, 3, 4, leaving room for F on 1, F on 5, and F on 7. And then, of course, M will end up going on 6 in the only slot remaining for it. Now, they're asking us what must be true. So if something did not occur in this diagram, it is not a must. Now, must F be on 3? We have S on 3, not F, so A is gone. Must R be on 4? That could occur, but we could also make a diagram with TSR on 4, 5, 6, F on 7, F on 3, F on 1. These diagrams are essentially the mirror images of each other, and what I mean by that is it's flippable. So F on 7, F on 1, TSR on 4, 5, 6, TSR on 2, 3, 4, F5, F3, M6, M2, F7, F1. This diagram is essentially the mirror image flip of the original while maintaining the TSR specific ordering as a box. So in this diagram, you see R could be on 6 or on 4. So we do not have to have R on 4. B is gone. Must we have F on 5? Happened in the bottom, but not in the top where we have S on 5, so C is gone. Must we have R on 6? R could be on 6, but it could also be on 4. So D is gone, leaving E by elimination. And if we look at E, F on 7 is consistent across both. So it's our answer to number 4. Next, number 5, if we had T on 1, we'd have to have S on 2 due to the TS box. And then we have our Fs, 3 of them not touching on 3, 5, and 7. Then we have M and R interchangeable on 4 and 6. I'm just going to kind of stack them, MR, and then RM on 6 as well. So those are essentially our possibilities for the game. We don't know exactly how M and R are playing out, but those are the 2 ways they can go. Now they're asking us when could R occur. R could be on 4 or on 6. 4 is not a choice, but 6 is. So 6D is our answer to number 5. Next, number 6, if M is the next after R, we've got an MR box, and of course we always have a TS box. So these are the 2 boxes that we're dealing with in the game. Now if you think about where those guys will go and how they affect the other variables. Remember, we've got 3 Fs. They've got to be spaced apart. They take up a lot of space. So we've got to make sure that we allow enough room for them. So one of Rm will go on 3. The other one, the other box, will go on 5 and 6 to leave room for F on 1, F on 4, and F on 7. Now, of course, the boxes could have also gone the other way. We could have TS on 2, 3, and then have RM on 5, 6. Those guys are undetermined, but the Fs are constant across 1, 4, and 7. So now let's just run through the choices. What must the fourth meeting be? Clearly F. So for that reason, A is our answer to number 6. You know, there's no one else who 4 could be, because we've got to have the F's spaced apart to allow room for these boxes. So A is our answer to number 6.